Hello, community. So great that you are back. Let's talk about vibe coding and maybe we can make a jump to vibe science. Let's have a look in detail. So let's start with vibe coding. Maybe you experienced it, maybe you say, what is it? Now, simply do a deep research on ChatGPT and after 16 minutes, the system comes back to you, says, yeah, I looked in detail 24 sources and I have now an idea what it is. It generated kind of in early 2025 with Andrei Karpati, and he said it's a new kind of coding, where you fully give in to the vibes, you embrace the exponentials, and you forget that the code even exists. This is quite a new and an interesting view here for a software engineer. Let's open up this video and see how we can use it and if there are some limitation to vibe coding. Now, the result of this deep research was that experience is required to supervise the AI because now the AI is generating the complete code without here, if you want, the human writing any code at all. So you might say, hey, this is great. But without any experience, they also state this vibe code could become unmanageable, a technical debt. And maybe vibe coding, you should not see it here as the tool, but not as a substitute for learning how to program, but maybe as a new layer. And we have educators worried that students might skip learning to code altogether and just rely on the results by the AI. And you might ask, is this a good idea? Now, have a deeper look and they say, hey, it's beautiful, two ideas come together. And now is the right time for vibe coding. Because you have this long-running trend of the automation of a programming task and the desire to democratize programming. So everybody can become a programmer. Everybody can ask an AI to write code and build your app, build your homepage, build beautiful software things. And this sounds great, eh? And just describe what you want and the AI builds it. And this feels honestly, intuitively, really exciting. I don't have to think anymore about how to build something. I just go to the machine and say, hey, I want this, and AI codes it, generates the app, generates a homepage, performs the task for me, and I just describe what I want. Doesn't this fit perfectly in our society? And yes, it also fits perfectly in the commercialization of global companies like OpenAI, because guess what? They are finding a new customer base. All the people that have no idea how to code, how to write code, now you can tell them, hey, listen, you have now all the options of a coder. You can do like somebody knows how to code. And isn't this great? You open up complete new markets with this. I want to show you an example that I chosen for a particular reason. You will immediately understand why. Now, here in Forbes, just days ago, at the end of March 2025, we have here a beautiful article in Innovation. What is vibe coding? Why should we care? Why should you care? And they say, hey, you know what? In this article, there's a person, and they had a week's worth of experimental data on a particular chemical process. So they provided this information to the AI, and the AI was able to find the correct mathematical equation to describe the process. And then after 15 iterations, so after 15 times that the AI wrote some code, tried to explain what's happening, and the human compared the numerical simulations with the real experimental data, after 15 times of going backwards and forward and whatever, then the human said, okay, now I felt that the simulation code kind of captured here the complexity of my real physical experiment. This human-AI interaction is now the interesting part. Because think about it. If you talk about chemical interaction, Niels Bohr, born in 1885, Nobel Prize in 1922, foundational understanding of the atomic structure with his Bohr model. Then physics developed, potential energy surfaced, the landscape where chemical reactions now are viewed as movements along a reaction coordinate. Electronic structures and molecular orbits came now into place. Then we have transition states, activation energy, critical high energy state, and barriers that determine here the reaction rates on a chemical reaction. then just think about the different types of chemical bonds, no? Think about what you know from school: covalent bonds, ionic bonds, hydrogen bonds, non-covalent interaction, pi-pi interactions, no? Imagine this person here was seeing just a numerical simulation by the eye, looking at her or his experimental chemical data, was able to understand, hey, there's maybe some, I don't know, hydrogen bonds missing. So went back to the AI and said, hey, AI, you forgot to include hydrogen bond. Or there was a non-covalent interaction I can see from the result of your numerical calculations. Please check now for non-covalent interaction and include this in the numerical simulation. So I think the amount of expertise you have in this particular examples, doing now chemistry, this is really quite a challenge, you know. I don't think I could do this just if you give me here experimental data from a chemical reaction, and I don't even know what it is, and I have to guess. So I think this is quite amazing here, because you can learn so much. Or think about this from a theoretical standpoint. Né? I, as a theoretical physicist, I would say, what about thermodynamics? What about here quantum mechanical description that are simply missing? What about we go with some macroscopic energy terms? What about we integrate here entropy, Gibbs free energy, enthalpy? What about all of this? What about this, seeing it from a different perspective, from thermodynamic quantities with quantum mechanics and statistical mechanics? So if you are able to get here the code that the AI writes, and you understand from the result of the code how much thermodynamic correction factors are in there, or how many quantum mechanical iteration terms are already in place, wow, I think this is really a system where you can learn a lot of. So therefore, this example of vibe coding, I think, is great to learn, because you interact here with an artificial intelligence, and you have to correct this, and you have a deep understanding of the complete theory of chemical reaction, and you have knowledge of all the different elements. Just think about the computational methods, if you think about computer science, no? How you write here your code, your mathematical understanding of molecular dynamics. I mean, you could go with the simplest Newtonian equation of motion, no? But if you go to quantum mechanical methods for the electronic interaction, you are in a complete different field. And especially if you then touch into density functional theory. So in general, the question is, the AI has access to free internet resources. But you know, those computational models that are available, the AI doesn't know anything about the theoretical background. The AI finds somewhere on the internet with an internet search some GitHub repo, and there's a simulation of chemical, I don't know, reactions of whatever. And then they use this model without understanding anything at all about the theory, what is integrated of a physical model, of a chemical understanding in this code implementation. And in general, I can tell you, if you have this software from the internet, neither those computational models are simple, nor are they correct, nor are they cheap. Because if you think about, if you study chemistry here at your university, you do have specialized software packages for the university, and they are not cheap at all, and they are not freely available on the internet in most cases. So you see, I think vibe coding, a great idea, as shown in this particular example, because if you study physics or mathematics or chemistry or whatever, you can learn a lot of here. If you have a week of experimental data, and then you say, okay, let's find here with AI a numerical computational simulation model, gee, you will learn so much about theory here. On what theoretical assumption was the code written, given that the AI now selected this free code sequence that it found somewhere on the internet? You have to understand just from the numerical situations here, what terms were integrated. Was it based on thermodynamics? Was it based on quantum field theory, or just quantum mechanical aspect? So you are really having here a steep learning curve. Now, interesting, as you see here, this vibe coding still demands here human oversight. Either in the feedback you provide, in the way you provide the feedback, in your specific prompt design, in the output validation, that you look at the code generated by the AI and say, hey, buddy, you missed your quantum mechanical term, you know, you were going here with a classical mechanical model, no? So there are so many things, but I think, and literature says also, vibe coding is most effective when the humans act here as an active element, as a control element here in this feedback, as an active steward here, looking at the AI-generated code and not as a passive consumer. Now, I know you might say, you know what, I don't care. I just ask AI to generate something. I understand nothing about coding. I understand nothing of the inner working of the system I want. I just let the AI do, and maybe I find a solution. Well, of course, this is one way to see this. But if you want to get the maximum benefit out of this new idea of vibe coding, I think this example here of an AI numerical simulation of a chemical reaction is a beautiful example how much we can learn. This is an interactive learning environment for us. Now, this vibe coding has another beautiful benefit of rapid prototyping. And isn't this great? But there's also the problem, if you look here at the result from ChatGPT of the deep research, that it potentially can introduce a disconnect, where the humans may not understand what is going on, may not understand what is the theory of the underlying code. In this case, we are encountering here not only from the learning phase a problem, but the companies that offer here this AI system, they noticed they encountered maybe a legal problem. And they found a beautiful solution for this. Because if you do something that you as a human may not understand, then guess who is responsible? Is it the system, the code that you use that is offered here for a very small price by the global AI provider? Or is it you, the human, who is responsible? No? Because you know what? This could be a product. And if you have a product, especially here in Europe, you have here a consumer protection with specific products. So now we enter suddenly a legal ground. And I think it's interesting to understand here the argumentation by the global reseller. Now they tell us vibe coding at its core, it reconfigures here the human-machine boundary. And as I've shown you in my example, yes, this is true. If you use it in the right way, my goodness, this is the ultimate learning machine, continuously challenging you. You have to know you have a deep understanding. You have to know what you're doing. So yes, absolutely. Vibe coding makes it viable to build your personal hyper-specific tools. If you were theoretical physics, working here at the interface here of quantum gravity and whatever, you need some really specific tools you cannot buy in a shop or somewhere on the internet, no? So isn't this great? And now the global corporation found that this hyper-specific tool idea also provided here from the commercial, from the legal, from the intellectual property rights sector here, from the being responsible for what you're doing here, a beautiful exit for them. Because guess what? We have now suddenly terms like software for one. One is not a market. One does not disturb a market. One is not within the competitive rules. You have a one-off automation created by one person, software for one particular reason. And guess what? It is not here commercially available. Because this software now serves here the smallest viable audience, as stated. This is one person, this is you. So vibe coding, and this is a beautiful marketing idea that secures here the legal assumption. Vibe coding personalizes here the computation. So this means if you are, let's say, OpenAI or any other global company that wants to maximize its profit, isn't this a beautiful idea? You can now offer your AI, because AI is doing here the coding of the vibe coding, but you are not responsible as a global corporation, because you say this is a software for one. You are not acting on the marketplace itself. You are here just for one, and one is just you. So this is the smallest viable audience. Therefore, if you think about it in legal terms, it's such a beautiful solution. So vibe coding has multiple perspectives to it. Now, of course, think about this. If I work with Manus here, I sometimes ask myself, this is interesting. You know what? Is it just a multi-agent coding? Well, how much is this already vibe coding? Is it more or less than vibe coding? What do you think? Because, think about it, vibe coding. So what we have two main elements, no? We have an AI, this is a code LLM or whatever you have, let's say Gemini 2.5 Pro, that writes your code application. It's the best AI model maybe on the planet. And then, if you have 10, 15 iteration, 10, 15 feedback loops, where you, as a human, you don't code, you don't maybe watch the code, but you can interpret the result of the code. Let's say it's a numerical situation of a specific chemical reaction. You see, oh, there are elements missing. You see spikes in the spectrum where you say, oh, I understand here, this was still the classical model. This did not have the correction for the quantum mechanical terms. So you have to have this knowledge, no? So the humans now understanding here the mistake that the AI make in the result, in the execution of the code, then this human has a beautiful task of only a deep understanding and steering here with a deeper strategic idea and a move and implement finally its creativity. And you see, we can now close the circle. Because wasn't this the idea of AI all along 5 years ago? Human creativity, this will be what human will contribute to AI. And now we found here a marketing story that finally closes, that is now coherent. And isn't this beautiful? And AI companies opened up here almost a complete population of this planet because you can do everything if you just pay the AI companies for their AI coding. Now, if we think a step further, you might say, why should humans have here this problem that they have to think and use their own brains? No? Hey, come on, this is AI, no? So let's say we substitute the humans because maybe you are not an expert in theoretical chemistry, in theoretical physics, and mathematical implementation of those. So you buy here an AI expert system. And you say, okay, I understand that there is a strategy that a human has to be the correcting factor, but hey, why not have another AI system? So we have now a multi-AI agent system. And this AI system here that I pay more has a better understanding. Maybe it's I don't know, a system that has much more free trainable parameters. And this new AI system provides now the strategic input that the human should provide. And this AI now learns what the human should have learned in this interaction with the machine. And now this AI is part that we can create a creative solution in a multi-AI agent environment. No? And this is beautiful because we kind of have an element of this. No? Think about all the GitHub, the Copilot, the Cursor, the Bold New and whatever. But think about what we have. We only have a code base, and sometimes we have comments, and sometimes we have short explanation in the code hidden here. But we have millions of repos on GitHub, and everything is available, and all the other code elements are trained on this. And you have AI generating our code base, so we have AI that feed off other AI generated code systems. So isn't this beautiful? But what we are missing is, if you want to have here a deeper strategic understanding, what are we missing? We are missing here an elementary part. We are missing here the deeper understanding of what is this code, because code is mathematics. So what is the mathematical description of what? What are the chemical processes that we try to quantize in mathematics and then try to encode in Python, C++, or whatever you like? So now we have this interesting move that we say, our GitHub Copilot, Cursor, whatever you have, this is just one part of the system. And the other part of the system, guess what? So let's come to the spark of genius moment in our video. And here you have it. End of March 2025, we have now a multi-AI agent framework for car design. And yeah, I just noticed here, those people just want to make sure that you really understand. Now, they are from the MIT, from the Massachusetts Institute of Technology, from MIT, and since it's about cars, of course, in Germany, the Technical University of Munich, BMW, and so on. So you see, they are now really interested here. They are working here with MIT to understand, hey, exactly in the topic we are talking about. So what we have software for sketching some ideas. Then we have software for CID generation. Then we have software for simulation and modeling of the car design. Then we have software for morphing and the optimization. Then we have a wind tunnel testing, and we have mathematical models that simulate a wind tunnel. And then we have a completely, let's say, automated manufacturing process to build this particular cars. If you think now about all of this here as a very specialized agent, you just have to input from one agent to the next agent, and we have this software already. We just have to have this intelligence level that is missing. And now with multi-agent AI, they are now exploring here with the help of MIT. Hey, can we do this with DeepSeek, with Claude, with ChatGPT? Can we apply our geometric deep learning models? Can we have here our graph neural networks here for the CAD agent, for the styling agent, for the computer simulation here of the wind tunnel, for if we have here a mesh model, we want to calculate here deformation here of all the different materials. The automobile industry, they do have their computer programs, and they are highly proprietary software. And if they now try to build here a chain of specialized AI agents to come here to this, if you want, vibe coding without any human coding, machine talks to itself. Isn't this beautiful? So we don't have to task, is vibe coding possible? I think they are actively researching here the complete virtual integration. Great. So what's the core idea? I talked about I want to achieve kind of a vibe science modality, no? But before we talk about vibe science, what we already have. And you might guess we are almost there. Let's have a look at this. About a year ago, I did this video here about science agents, Stanford University and MIT, and I compared here their scientific agent in their graph reasoning capabilities. I did, I think 6 months ago, this protein design by AI here for medicine, for material science, for biotechnology, for pharma, and we looked here at molecular language model here of proteins, diffusion models, and we looked here at the potential that AI have in designing here specific proteins for industry. Just days ago, I published this here, the CodeScientist, this Google, Stanford, Harvard CodeScientist, the science that you want, I called it. But of course, we have other papers here, like here from beginning of 2025, AMD and Johns Hopkins University, where they use LLM agents as a research assistant. So you see the topic is here for the last 2 years minimum. And we have here exactly what we are missing. Have a look at this. Do you see it? The paper of today is this one. This here is by Allen Institute of Artificial Intelligence here in University of Washington. And here Peter Jensen here from Allen AI. It's a beautiful paper here, March 20, 2025, CodeScientist. And end-to-end, you remember, the automobile industry, semi-automated scientific discovery with code-based experimentation. Now, this is a new topic. We say autonomous scientific discovery, ASD, of software artifacts. So whatever we can build a virtual model, whatever we have a numerical situation, or a numerical simulation, wherever we can simulate here the wind tunnel, where we can simulate chemical reaction, where we can simulate here aesthetic design, and we have, 10,000 people that give you their opinion on this design, we can build an AI system out of this. And then we have here multiple agents, and if they interact, isn't this interesting? Now I told you, we're almost there, and I ask you, do you see it? I'll give you another hint. So if we just look here at the agent laboratory here, what we have a complete GitHub with all the experimental configuration, with the data, with the Python files here, the Python code to run this experiment, to run here, or to be here an agent, to be here a helpful research assistant in a laboratory. And the code is here, but what is missing now for the next generation of AI is exactly the theoretical understanding, the linguistic thought process that went into the generation of the code. Why have we encoded here in Python our thoughts of what is to do in this particular way? You cannot deduct this from looking at the code base itself. You have to understand the model, the thoughts behind the creation of these models. So what we have now is, now you say, hey, I'm not satisfied with a cursor implementation of pure code. Now the next generation of AI models will combine both. Will combine here the complete theory, the complete model, the complete history in the development, the complete need for an AI research assistant with all the thoughts that are then implemented, because now if you combine this in a perfect way, this AI is really able to understand why the code for the Python agents looks in this particular way that it really looks, and what are the limitations. Because the limitation you do not find in the code, but you find here in the development of the theory and then of the mathematical formulas. And you know, mathematics is code, and then of the code implementation. So now we train our next AI systems on the combination of this. And this already happened here in the paper that we're going to look at from Allen AI. And I think it's a beautiful paper. So let's have a look at this ASD, this automatic scientific discovery. And you might say, what? Science? They take away science from our human thought, and this is so beautiful to think about and perform science. Yes, every sector is now here with AI. So let's have a look at the complete process flow. This is what they built. They say, okay, we have a human, and the human provide here some paper of interest, some scientific papers. Isn't this great? And the human now says, let's go there. Okay, I have this paper. And there is also a GitHub repo. Now I provide here the code, I copy the GitHub repo, I provide here the code, and I provide here the theory and the linguistic here, understanding here, together here with the code blocks. And then this is done by the human, great. And now we feed this into our AI system, and we have here an LLM as a mutator. So input is now the papers and the code, and output should be now new ideas. We call this the ideation phase. Generate batch of candidate ideas. If you ask here your staff, hey, be creative, come up with new ideas. This is exactly what the AI is now tasked to do. So then the AI generates, 200, 2000 ideas. And then here in this particular case, in this particular publication, there's another time a human, and the human or multiple humans select now a subset. They read here all the AI generated ideas, and then they say, maybe this could be it, and this is absolute nonsense. So the humans select the most promising ideas. And then, this is important, the human write here a feedback. They provide here comments on each idea, and of course in a structured data way and whatever, you get the idea. And then we feed this back to the AI system. And now maybe we have another agent, a planning agent, no? And guess what? This is now here, in particular, they use GPT-4 Omni Mini for this LLM, no? And now, if they say from those selected promising ideas, where we have additional comments here by the human how to implement it, and we have code from the 20 papers surrounding this particular idea, we should now have a planning phase. We should now create a strategy to create some plans how we could really do this in code. And we selected, of course, only the best one, and then we have this experiment. So we create here now the code, and we run the code, and we have here results from the code that is more or less here the result of the experiment that we do. So you have the library of all the code blocks that you need. Then you have the code generation, take cursor or bolt or whatever you like and have. And then you have some results. This is AI generated. No? You have reflection. The AI can maybe debug if you have pay for a better system, whatever. And then after you run a particular item, you have a reporting. So your AI writes summarization, results. You have the written report, and then you have another AI agent It does now a cross-experiment analysis, look at all the different reports, analyzes what happened here, why was this successful, why was this not successful, why did this provide inconclusive results, and you could in theory start all over again. Or you say, okay, this is good enough for me, and have another human now at the end of this process that verifies the code and results, examines the code, has a complete understanding of the complete theory, what is behind the code of the complete mathematical abstraction, how we calculate this experiment, what formulas we use here. Let's say this is here our chemical reaction experiment. How much of the quantum correction terms do we use? How much we rely on classical systems? How much we integrate all the different chemical bound structures that we know from the Niels Bohr model? So there's so much to do. And they had here these human interactions. So you could say, okay, isn't this kind of a vibe science somehow? Because we do have this human feedback in the loop that provides a strategic reflection, strategic feedback. And then you have the question, why do we need the human? It is so easy. If we have already a multi-agent system, you know what? We have an agent that just goes out on the internet and looks here on the GitHub repos here for, 20, 100 GitHub repos that have code for our particular problem or are close to our problem. Select a subset of promising ideas. Why is not an AI agent possible that says, okay, I look now at 2,000 ideas coming back and I have defined a specific filter for this? This could do an AI agent. Comment on ideas. Hey, this is the base, the bread and butter here of any AI agent. So there's no problem at all of doing this and having now AI agents here in the loop. And the human is just looking here at the absolute end result. And this is now interesting. Even if we have the human in the loop, what do you think is the overall outcome of this? How good are our AI system if you really run this, if you invest this, if you build this, if you hire humans to do all the selection and do the comment writing to each idea and examine and verify, if we have all those humans, how good is our success rate? What do you think? 50%? 70%? 90% success rate? I just want to show you here the prompt itself, really from this experiment, because Alan and I, they really did this experiment, and I think it's beautiful. And they are so transparent. They give you here the planning prompt. They say, hey, you are here the most advanced automated scientific model in the world. You can use your enormous intellect. It sounds so similar. Yeah, and the building is template-based, so you have multiple tries to use existing code templates to build your experiment with this, and you get the idea, no? And they really give you this here for each and every prompt. Then you have the experiment debugging prompt, tell you, hey, now your role is this. Then you have the reporting prompt. Guess what? Your task is to reflect on the goal of the experiment and the results of the experiment and write a short description of the findings in the form of a short scientific paper in LaTeX. Guess what? The next one is the experiment summary prompt. Now your task is to reflect on the goal of the experiment and the results of the experiment and write a short summary of the findings. What was the hypothesis? Now we need the theory. Now code is not enough anymore. No? What did the results show? You have to interpret the numerical simulation results. Therefore, you need to have a theoretical understanding of what is happening, what was the code based on, what were the limitations of the code base, and so on. The next one is the meta-analysis prompt. Yes, you get it. Then we have here finally, and this is just what they showed us here, February 15, 2025, by an AI with human help, we have now a new scientific paper. And interestingly, they send it off, and guess what? Yes. So let's come to an end. Isn't this interesting where we are currently with our AI development? Now let's come to the result. How good is this? We want to have a benchmark. We want to have a performance data. So the idea selection phase, so what we started with, we as Alan AI here, they used here the CodeScientist that I just showed you to generate about 2,000 candidate experiment ideas. How many of these 2,000 experimental ideas were successful. I give you the result. They were talking about how much is it incremental innovative or how much is it a transformational discovery, unbelievable new breakthrough in theoretical physics. Well, it turned out that the 3 external reviewers suggested that each candidate, and this was not a lot of candidates, the CodeScientist discovery is at best an incrementally novel idea. Yeah? So from this 2000, they broke it down to 6, where human expert validated the 6 discoveries that maybe this 6 has something to it. Yeah? And then ask about how disruptive this is. No? At best, an incremental novelty. So you would say, hey, it's not working at all. This would not be true. This is just the very beginning. This is just, the alpha phase. This is just where we say, how can we combine those AI systems? Now, there's still a lot of way to go to improve those systems, But in our thoughts, we can do a Gedankenexperiment. We can say, why stop here? No? Why stop just with the theoretical understanding of an experiment and the code implementation of this experiment? What would be the next step? What would be the outlook maybe for my next video? And it is simple. Whatever we know with vibe science, whatever you like to call it, what about we go the next step in the abstraction and we do vibe AI? But this would be the topic for my next video. I hope you enjoyed it, or maybe you found some new ideas. If you subscribe, I see you in my next video.